Hello, my name is Jingyi Zhang and I'm from University College London. Today I'll be presenting our paper on single actor controlling multiple avatars for social virtual realities. Let's start with the motivation. Social virtual reality has gained popularity in various fields, including entertainment, such as VR shows or theaters, social virtual reality games, and training for educators and healthcare professionals, and psychological research. A key element of social virtual reality is facilitating social interactions between users and multiple virtual humans. Despite advances in crowd generation and AI agents, existing technology still struggles to create virtual humans that respond naturally in open-ended scenarios where users have full freedom in interactions. Even as technology advances to create realistic virtual humans in VR, human intervention is still essential for directing narratives, ensuring credibility, and handling unexpected situations. Instead of adding a new virtual human into the scene, it's more practical for an actor to take control of an existing one. Therefore, we built a system that enhances a single actor to control and embody multiple virtual humans. So there are two phases. Virtual humans are animated with pre-recorded motion during non-interactive phases, and the actor takes over control when interaction is needed. Our system supports full-body avatar with 6-point tracking. Additionally, there is a voice modulator that adapts the actor's voice to the unique one for different virtual humans. On the left is what the user sees. They can view multiple virtual humans in the scene moving naturally, so here you can see 2 of them. On the right is what the actor sees. When interacting with the user, the actor takes control of a selected virtual human, following the rule and scripts for that character. When not interacting, actor observes the scene and selects on the map panel for the next virtual humans to take over. All the blue dots here represent a virtual human that could be controlled by the actor. And the red is where the user is, and the yellow one is where the actor currently is. We conducted a user study to explore participants' reactions to multiple virtual humans being controlled by a single actor during interactions, and to assess whether this method enhances co-presence. There are 2 conditions. We compared our approach with a Wizard of Oz setup, which simulates character control methods by triggering pre-recorded responses based on user input, similar to how it is done in modern computer games. We created a virtual museum with 5 unique virtual humans. Participants took on the role of an intern on their first day at work. A supervisor explained their task, which was to collect feedback for visitors and report it to a colleague. So there's 5 virtual humans with distinct roles and response styles: a supervisor, 3 visitors, and a colleague. The participant starts here, then this is their supervisor, then 3 visitors, and finally reported to their colleague here. There's 40 participants in total. The measures included questionnaires followed by an interview. Our hypotheses were the number of human-controlled virtual humans perceived by the participants, the number of humans perceived interacting with the participants, and the co-presence perceived by the participants in C takeover, which is using our system, will be higher than the one in C recorded, which is the Wizard of Oz setup. I will play a short video to demonstrate the experiment.
Hey there!
Hello.
Hey, welcome to your first day.
Thank
I'm
you.
the supervisor here at the museum.
I just wanted to know what is your overall experience of our exhibition?
Okay, I like the exhibit. The arrangement is good and they've got quite a nice atmosphere.
Did you enjoy it?
For this museum, well, it's all fascinating, but a bit overwhelming. Maybe some.
Ooh, okay. Ask you, how do you enjoy the museum? I'm working here. I would like to have the customer point of view.
Sorry. Sorry, I prefer not to comment. Yeah, sorry.
It's
Sorry.
alright. Thank you.
Hey, very nice to meet you. I am Jack.
Hi, nice to meet you. I just started today.
Okay, the result. The number of human-controlled virtual humans reported in C takeover with our system has a mean of 3.2, was higher than the one in C recorded with a mean of 2.3. So if you still remember, there's 5 virtual humans in the museum. Participants received interacting with more humans in C takeover with a mean of 2.7, compared with C recorded with a mean of 1.8. And comparison scores for our system were also higher. Participants discussed why they perceive some virtual humans as human-controlled. Initiating interaction, they expected virtual humans to look at them when approached. Some felt virtual humans should respond only after being spoken to. Quick response speed suggested human-controlled but delay sometimes seen as network lag. Relevant and detailed answers are expected. Repetitive or overly fluent responses seemed scripted. More interactivity is more human-like. If interaction is too short, then less human-like. Natural body language, facing direction, and human-like audio are also important. Attitude and emotional realism, so reluctance of one of the visitor and the positive welcoming attitude of the supervisor could be a reason. Several factors helped the participant to determine if virtual humans were controlled by the same person. First, voice, tone, and accent. Some participants noticed similar sounds between two visitors, while others found them distinctly different. Even when tone and accent sounded similar, distinct voices of genders led them to perceive separate humans. Attitude also played a role. Participants noted different communication styles, such as positive or neutral, influencing their perception of separate controllers behind. Lastly, 6 participants made assumptions based on the feasibility of the technology. They speculated one person could control all interactions, especially since the virtual human didn't interact with each other. We invited another 4 participants with performance experience to provide feedback on our system. This partly addressed a limitation of the main study where the actor was an experimenter with substantial prior knowledge of the system's operation. This test demonstrates that little training is required for novice actors to portray and switch control between multiple virtual humans, thereby evaluating the feasibility of the system. We demonstrated a VR game or show example where fewer actors are needed to save human resources, but the system also has the potential to be used for training purposes. For example, for teacher training, we can generate a classroom of students, and a senior teacher may control some of them and do something, then the junior teacher learns how to handle it. And also psychological researches for social interactions, so you don't have to hire a lot of actors. For future work, we aim to address 4 limitations for our system. First, the blending animation is currently linear and depends on the distance between poses. We plan to explore generative models for smoother transitions. Second, the non-interactive animations are relatively simple. Motion generation techniques could enhance behaviors during these phases. Third, choosing which virtual human to control can be challenging. We are considering the use of a director or AI assistant to help actors decide the next steps. Additionally, content summarizes and AI-generated replies could ease the transition for the actor. Finally, the system has potential to handle densely populated environments. We aim to explore multi-actor control for crowded scenes and plan to integrate hand tracking and visual expression for more realistic movement and behaviors. Thank you.